Yes, I can hear you. Yes, sir.
So, Aditya, now let me know which chapter you want to start with.
So could we start with electrolysis?
Electrolysis, right? Aditya, which book are you following?
So I'm using the Essential Chemistry for Cambridge IGCSE from
Okay,
Oxford.
okay, you're an IGCSE board, right? So, I'm starting with, before I start with electrolysis, I need to understand the concept of what do you mean by the word electrolyte. Do you know what is electrolyte?
An electrolyte is a molten or aqueous ionic compound uh, that uh,
Right on, right on. The substance that does not conduct electrolysis, does not conduct electricity in solid state, but conducts in molten or aqueous state. Which does not conduct electricity in the molten or aqueous state, which conduct electricity in molten or aqueous state, but not in the solid state. For example, if I say I have a sodium chloride, have you seen sodium chloride practically?
yes, stable salt.
Yeah. In the solid state, does it conduct electricity?
No,
If I connect here with a wire, with a battery, and to detect the current, I'm putting here either galvanometer or voltmeter or ammeter.
no, sir, it doesn't work if
Yeah.
it's solid.
But the same sodium chloride, if I melt it, it changes to its ions, right? It changes to its ions. And this ion, we pass a current, negative terminal, positive terminal. These ions will move towards the oppositely charged electrode. Negative charged electrode is called as a cathode, and positively charged is called as an anode. You got this thing? Yeah, no? Yes, no?
Yes, sir.
So at cathode, what will happen? The sodium positive ion will be gaining electron and become sodium. It means sodium will be deposited over here. And at anode, the Cl negative will be losing electron, and two such chlorine atom will combine to give Cl2 gas. And here the gas will be liberated. Am I clear?
Yes, sir.
So note it down and let me know if you find any difficulty in it.
Yes, sir.
Now, I have a lead bromide, PbBr. When I melt it, it turns to its ions, Pb2 positive and Br negative. Are you getting this?
Yes, sir.
Now, when you're passing current at cathode, what will happen? What is the charge of the cathode?
Cathode is negative.
Yeah. So there, the lead 2 positive ion will be gaining electron and become lead. It means lead is deposited over there. And at anode is a positive charge where the bromide ion will be losing electron, become Br atoms, and two such Br atom will combine to give you Br2 gas. Br2 is liquid. Am I clear?
Yes, sir.
Note it down. Understood?
Yes, sir.
Now, if I have an aluminium oxide,
AlO3.
can you tell me the formula of the aluminium oxide?
AlO3.
Al2O3. I tell you how. Aluminium is having 3 positive ion and oxide is 2 negative ion, right?
Yeah.
They just interchange, right?
Yeah.
So when in the molten state, they will be reducing these ions, 2 and 3. So at cathode, these aluminum ion will be gaining electron, undergo reduction, and they form aluminum. Gain of electron is called reduction. Write down here, gain of electron is called reduction. At anode, these will be losing electron, and two such oxygen atom will combine to give you O2 gas. It means at anode, oxygen will be liberated, and at cathode, aluminum will be liberated. Done. Understood?
Yes, sir.
And now we have copper bromide. Copper bromide formed like BCuBr2. Can you tell me what will be formed at cathode and what will be formed at anode? Right.
So at cathode would be Cu2.
See, first of all, what you do, don't make any prediction verbally. You dissociate into its ions.
Yeah.
Right? Don't do it mentally. Dissociate it. Write it. And now at cathode, these copper ions will be gaining electron, become copper. It means the copper will be deposited at cathode. And at anode,
Will be losing.
Br negative ion will become a Br right? And two such bromine will give you Br2. It means at cathode copper at anode Br2. Am I clear?
When we did in school, I know it was Br minus minus electron equals Br.
Yeah, it is same thing. I'm writing here plus
Okay.
electron, or you can write like this also. You can write like this also. Understood?
Yes, sir.
You can write either, you can write here plus electron, or you can write here minus electron. Minus electron on the right hand side, or product plus electron on the product side. You can write any one of the two. Understood?
Yes.
Now, can you predict for zinc chloride, ZnCl2? What you do is you dissociate and then make it.
So the ions would be zinc 2 plus
Hmm.
and Cl minus.
2Cl chloride.
Yeah, 2Cl minus.
Okay. Now
So at the cathode it would, yeah, at cathode it would be zinc 2 plus minus 2
no,
electrons.
they'll be gaining electron.
Yeah, plus
Hmm.
that forms is Zn2.
Hmm. Now, I can show
So
you
when
one
we zinc 2,
thing.
so when we zinc 2,
No, zinc 2
then
positive, it has gained 2 electron, becomes zinc.
okay.
And now that will be losing electron here. And two such chlorine will combine to give you Cl2. Understood?
So,
Yes, Aditya, let me know which topic, which part is not clear to you.
I'm just writing down the zinc chlorine.
Not understanding zinc chloride.
So I'm just writing it down. Just give me one moment.
Okay.
Yes, sir.
Now, I have a question. What type of compounds can be electrolyzed? What type of compounds can be electrolyzed? Can you work upon it?
Non-metal and non-metal.
No. Ionic compounds, which can give
Okay.
ions. Write it down. Now here I have a question. What conditions are needed for the electrolysis?
Um, the compound should be in molten aqueous state.
Good. Salt must be, you can write it down, must be in molten or aqueous state. Right?
Yes, sir.
Today I started with sodium chloride. Right? What is
Yes.
the state here? What is the state here?
Uh,
It's a
that is
molten
solid.
state. It's a molten state or the aqueous state or what?
It is a molten state.
Molten state. In the molten state, at cathode, I'm getting here sodium. At anode, I'm getting chlorine. Right?
Yes, sir.
But now I'm doing something different. I'm going for electrolysis of aqueous sodium chloride. When I say aqueous, that stands for when dissolved in water. It means this NaCl has been dissolved in water. It forms a Na positive Cl negative, H positive and OH negative, right? At cathode, what will happen? Two ions are there. Cathode is negative charge, where sodium ions and H positive ion both can take up electron. If hydrogen gains electron, that will produce a hydrogen, H2. If sodium gains electron, that will become here sodium. Now, out of the two, which will take place? Out of the two, which will take place? Can you tell me?
So it depends on the reactivity.
Yeah, reactivity, which is more
The
here.
cathode.
Yeah. So which will take place here?
Uh, Na plus and
No. Write down
the
for the
hydrogen will react.
discharge series. Write down discharge series. Sodium positive, magnesium 2 positive, aluminum 3 positive, H positive, copper 2 positive. In this series, more likely to be discharged. Likely to be discharged. It means out of sodium and H positive ion, this will take place, this will not. Hydrogen has a more tendency to gain electron as compared to sodium. And for the anions, sulfate ion, nitrate ion, OH ions, Br negative ion, I negative ion, more likely to be discharged. More likely to be discharged. So here, out of the sodium and H positive ion, hydrogen has a more tendency to lose electron.
Okay.
Right. Note it down.
So, but even H plus is also in the group.
H positive ion has more tendency to gain electron as compared to the sodium. But if I compare copper and H positive, the copper will be reduced.
Okay. So could you note bit off so I could note down the
Have you noted down?
so could no so the I want you to note down the ions.
Have you done
It's
that?
NaCl aqueous, right?
No. Okay.
Yes, sir.
Now, at the anode part, here I have chloride and OH. Out of these two, which will be attracted towards the anode, put here chloride also. Right. So the chloride and OH, out of these two, the chloride ion has a more tendency to get discharged. It means at anode, I have two ions, one is chloride ion, other is the OH. If it gets discharged, right, then two such chlorine atom will give you Cl2. Or the 4 OH ion will give you two water molecule plus oxygen minus 4 electrons. It will give you oxygen. But one of the two will take place, the one which is more likely to be discharged. And you can see the chlorine has more tendency to get discharged. So the chlorine will be liberated, but not the oxygen. Getting my thing?
Yes, sir.
So here, this sequence you have to remember. This and this sequence you have to remember.
So after NO minus 3 nitrate, after nitrate, what is the next compound?
Magnesium.
No, so that's not sodium nitrate. The next one.
OH negative ion, hydroxyl ion.
And so after OH negative.
I'll write it again.
Okay.
Sulfate ion, then I have a nitrate ion, then OH negative ion, then Cl negative ion, then Br negative ion, then I negative ion. Chloride ion, bromide ion, iodide ion. This is the more likely to be discharged. More likely to be discharged. Getting my Aditya?
Yes, sir.
If you're not clear, let me know.
So I'm clear. I'm writing. Yes, sir.
Understood?
Yes, sir.
It means when we electrolyze sodium chloride in the aqueous medium, I will get the hydrogen at the cathode and chlorine at the anode, right? Am I clear?
Yes, sir.
What is left in the solution? Which ions are not discharged? Sodium ion and OH ion, they are not discharged, right? It means after electrolyzing it, we will be left in the solution sodium hydroxide. This phenomena by which we can produce a sodium hydroxide. To prepare a sodium chloride, sodium hydroxide, we can go for the electrolysis of the NaCl. It means if you go for the electrolysis, if you do the electrolysis of sodium chloride aqueous solution, after that hydrogen will go as a H2 gas, chlorine will go as a chlorine gas, and in the resulting solution I will have a sodium hydroxide. Got
Okay,
it?
so they both. Okay.
Understood?
So could you just explain it one more time?
Okay, yes. Okay, what I do, I'll show it experimentally like this. I'll show you like one experiment here. Here I have porous membrane.
No, so what is that?
Here I have sodium chloride solution. Right?
Yes, sir.
Here also. Here also I have sodium chloride solution. And now here I have the current connected with the positive terminal, connected with the negative terminal. Right? Understood this much?
Yes, sir.
When I say sodium chloride solution, it contains sodium, ion, chloridine, and dissolved in water that has got dissociated as a H positive and OH negative ion. Yes or
Yes,
no?
sir.
Now, when you're passing the current at cathode, cathode means negative terminal, right?
Yes, sir.
H positive ion and the sodium ion, out of the two, which has a more likely to get discharged? Tell me from the series.
Hydrogen.
Hydrogen. It means that this will undergo reduction, and two such H atom will give you H2 gas. Understood? It means from here, from this outlet, I'll get the hydrogen gas out. Getting me?
Yes, sir.
Now, at anode, what will happen? I have two things, Cl negative ion and OH negative ion. Which is more likely to get discharged?
Cl and OH.
Cl
So
negative, right?
yeah.
It will be now losing electron.
No, OH would.
No. See, I have given here very clearly. See, chlorine is more likely to get discharged.
So okay, on this one the order is from the other side.
Yeah. So
Okay.
two such chlorine atom will combine to give you Cl2. It means from this outlet, the chlorine gas will come out. Now, what is left inside now? Can you tell me? Sodium ion and the OH ion. That is left in the solution, and that we can take out from here as a sodium hydroxide. Understood? Yes or no?
Yes, sir. Yes, sir.
So in case of aqueous solution, you have to see which ion has a more tendency to get discharged.
Yeah. Okay.
Now, should I go ahead? Have you noted down?
Yes, sir. Noted.
Before I go ahead, I'll ask you some simple question. I have here sodium chloride molten state. What product is formed at cathode and what product is formed at anode?
Okay, a cathode, in a cathode is Na positive
No,
and
what is produced? Sodium ion will go and get
oh,
reduced.
NaNCl,
Not Cl, Cl2. Because
NCl2,
chlorine
sorry.
atom is nothing. Right? It is always formed as a
Yeah,
Cl2.
it's diatomic nature.
Right. And now if I have an NaCl and it is an aqueous solution, what is produced at cathode and what is produced at anode?
Uh, at anode it is Cl2,
Hmm.
and at cathode it is hydrogen 2.
Right. H2gas. Understood now?
Yes, sir.
It means what product are formed that depends upon the nature of electrolyte, whether it is a molten or an aqueous. Aqueous means when dissolved in water. Molten means just melted,
Yeah.
right? Similarly, I have here just a minute. I have here cupric chloride CuCl2 aqueous solution. Now, can you tell me what will be formed at cathode and what will be formed at anode? You can check the
Aqueous, so
discharge
okay.
theory.
Yeah. It should be a hydrogen be formed at cathode
No,
H2.
you are not looking at the
No,
series.
C. Yeah, Cu. Yeah, C. Okay.
Yeah. That is more tendency to get discharged. And what about the anode?
Cl2.
Cl2. Okay, now I'm giving you hydrogen bromide in the aqueous
Hydrogen
solution.
bromide.
Yeah.
It's hydrogen
H2.
H2.
Yeah. And at the anode,
Brom bromide.
Br2. Right? I have sodium iodide, NaI. Now what at cathode and what at anode?
Sodium iodide. It is hydrogen H2 and iodine itself.
I do. Understood?
Yes, sir.
Now, here I have potassium iodide.
Potassium iodide. So it will be H2
Hmm.
and iodine itself I2.
Right. Okay. Before I go ahead, okay, you have to tell me what will be left in the aqueous solution. Means here in aqueous solution, copper has gone and chlorine has gone. What is left in the solution? Which ions are left in the solution?
And first one will be hydrogen.
And OH ion.
Oh,
Right? Water has a
hydrogen and so it is H2O.
H2. The solution, resulting solution will be acidic, alkaline, or neutral.
Neutral.
Neutral. Okay, what about the second case?
So it would be so what would be left is
Some H positive ion will be left. No, it will be all reduced. But will be having left the OH ion.
Yeah, OH will be left.
So solution will be alkaline or acidic or neutral?
Neutral, right? No, alkaline.
Alkaline, yeah. Now third case, sodium iodide.
Sodium iodine, since it's H2, so it will be sodium.
Hmm.
Sodium, sodium and OH negative will be here.
So sodium will be left from here and OH ion will be left from here. I'll have a sodium hydroxide.
Yeah.
Yes or no?
Yes, sir.
So what type of solution is NaOH? Alkaline?
NaOH is acidic.
Alkaline. The one which gives OH ion is alkaline. The one which has extra H positive ion, that is acidic.
Yeah,
Okay. Yes or no?
Yes, sir.
If you're not clear, let me know.
Potassium.
Yeah.
Yes, I'm clear. Sir. Potassium iodine, potassium will be left over.
Yeah, potassium will be left over here.
Potassium and OH. So it will be alkaline.
Good. Now I'm giving you sulfuric acid, H2SO4, aqueous medium.
So it will be H2 would be the thing, cathode,
At H2, okay.
and it will be OH.
OH. If that gets
Minus
discharged,
four.
it will produce oxygen gas.
Yeah.
So what is left in the solution only?
In the solution, what is left is
Polysulfate ion.
sulfate. Yeah, sulfate is alkaline also, right? No, sulfate is acidic.
Sulfate is
Alkaline.
no, nothing. Neither acid nor basic. Only sulfate ion are left. That's it.
Okay.
Right. Okay. No. I'll not define what do you mean by the word oxidation and reduction.
Oxidation is Oxidation is loss in electrons,
Yeah.
and reduction is gain in electrons.
Loss of electron is called oxidation, and reduction is
Gain.
gain of electrons. So if I say lead positive ion is gaining electron to become lead, then what is happening here?
Lead positive is gaining electron to become lead.
Yeah.
It is reduction.
Reduction. It means lead ions are undergoing reduction, right?
Yeah.
Okay. And now if I say I negative ion are losing electron here and become I2
Oxidation.
and I2. So what is happening here?
Yes, oxidation.
It is oxidation.
Oxidation.
Now, if I say that the electrons that are lost by the iodine are gained by the lead, it means for the reduction of the lead, iodide ion is giving electrons.
Yeah.
So this iodine will be acting like a reducing agent. Or we can say lead ions are pulling or snatching the electron from the iodine. This is oxidizing.
Oxidation.
So oxidizing agent itself undergo reduction and reducing agent itself undergo oxidation. Understood?
Yes, sir.
Aditya?
Yes, I understood.
Note it down. This is called as a reduction half reaction. It's a half reaction. This is a oxidation half reaction.
Yeah. Oxidation half reaction means is one part of the
Yeah.
that is
Overall,
only the anode.
overall, I can write lead 2 positive ion and 2 I negative ion to give PbI2. In this reaction, lead ions are undergoing reduction, iodide ions are undergoing oxidation. So overall, it is called as a redox reaction. Overall, it is called as a redox reaction. Overall, it is called redox reaction.
Yes, sir.
Understood?
Yes, sir.
Now, write half equations for the following. Aditya, could you please just give me a minute, please?
Yes, sir. Yes, sir.
Hello. Yes, sir. Very good evening. Not today. Not today. I'm not at my place. Today. Not today. Any other day I will be. We can do at 10 o'clock. Then will be okay with me. I'll be reaching home before 10. Okay, I'm not at my home today. I'm not. Okay, okay. Sure. Okay. Fine. Yes, Aditya. My question is lead ion reacting to form lead. So how will you write the half equation?
So one half of the equation would be the cathode, and the other half would be anode, the
No, no,
electrolyte, sir.
no, no, no. Only for this. Only lead ions. Just give me a second, please.
Yes, sir.
Yes. I am saying only the lead ions, right? That has to become the lead. So what should I write here?
So it will become lead there plus two electrons.
Two electrons. At which electrode it will be there? At which electrode it will take place?
This will be taking place at the cathode.
Good. Cathode. This is a reduction or oxidation?
Or reduction.
Reduction. This is a reduction half reaction. Am I clear?
Yes, sir.
It's a half reaction. It is not a complete reaction.
Complete reaction will involve the ionic side also.
Yeah, it's only half part because
Okay.
it is undergoing reduction only. Reduction reaction is nothing. Without oxidation, reduction cannot take place.
Okay.
To reduce a lead ion, somebody should be able to give electrons.
Yeah. Okay.
Right. Just like this, here I have said the iodide ion is giving electron and the same electron are taken up by the lead.
Yeah. Yes, sir.
It means without oxidation, reduction is not possible. And without reduction, oxidation is not possible. Both has to take place simultaneously. Understood?
Yes.
It is just like this. If you are not there online, can I teach you? No. Okay.
Sir.
Another point. Right now, if I am not online, can you learn from me?
No, sir. So both of them have to be there for
Yes.
location.
Without student, teacher has no meaning. And without a student, without teacher, student has no meaning. Right? The process will take place simultaneously. One will be losing electron, other will be gaining electron. So we call it a half reaction. Okay, now I'm giving you another question here. Hydrogen ions reacting to form hydrogen gas. Can you work upon this?
Hydrogen ions. So that's H2 plus.
Repeat, please.
So that's H2 plus
H positive ions.
yeah, so plus
Mhm.
electron
Electron
is what?
to give
H
and H2 gas means I
H2
need here two electrons.
two electrons and
Understood now?
yeah. Yes, sir.
And you have to mention here aqueous and this is the gas. Mention the physical state. Okay. Here also, here we have an aqueous, it's a lead as a solid. Getting me?
Yes, sir.
I'm giving you now hydroxide ion reacting to form oxygen and water. I have given you this reaction earlier. Can you recall and write?
Okay, hydroxide ion reacting to form oxygen and water. This is the reaction of the anode for um. So it would be uh
See,
uh,
see here.
it's OH.
OH negative ion.
Yeah, minus
Giving you to what? Water
H.
and oxygen, right?
Yeah.
And now you have to balance it.
So it would be 2OH.
See, I have here 3 oxygen, multiply here the 2, I will have 4 oxygen, make it 4 here, and now here we move 4 electrons.
Okay.
Okay. It's a aqueous, it's a liquid, it's a gas. Yes or no?
Yes, sir.
Aditya, in your book, Essential Chemistry, I think it's on page number 76 somewhere. Do you have book with you right now?
Yes, sir.
I think that must be in somewhere 76, 77 page number somewhere.
Yes, sir.
These questions have been given over there.
Yes, sir. So many questions.
Yes or no?
Is it the summary questions?
Yeah, summary questions. The same questions I'm getting from you because I have PDF book with me. You have a hard copy. You can see summary questions have been given out there.
Yes, sir. Uh,
And if you see the last question number three, can you read out the last question number three?
yes, sir. State the name of the products formed at each electrode when concentrated solutions of following are electrolyzed. A. Copper chloride. B. Hydrogen bromide. C. Sodium iodine.
I don't have that question with me.
Okay, sir. I can send a picture of the question to you, sir.
Yeah, yeah, you can. You can send on the WhatsApp. You can send me.
Okay, sir.
You have my phone number with you, WhatsApp number.
So my mom is sending active.
Okay, okay, fine. I'll be sending you this PDF file as well as the class recording also on your email ID. Yeah, I have received. I think this question we have done, right? Yes, Aditya. Aditya, I can't hear you. You are muted.
Yes, sir. Yeah, yeah. We have done this one for the products.
Yeah, we have done this question earlier, right?
Yes, sir.
I think you can do it, right?
Yes, sir.
Perfect. And now I have. I think that the topic of the electrolysis is not complete.
No, sir. It's not.
Something is left.
Then there is the electroplating.
Pardon?
Then there is purification of copper, purification.
Yeah, yeah,
Then
that
there
is
is electroplating.
that is left. That is left. We will be
Then
doing it.
extracting
We will be doing it.
aluminum.
We will be
Yeah.
doing it. Okay, before I go ahead, do you have any doubt in this topic today?
No, sir.
You got it? What is oxidation? What is reduction? What is the
Yes,
half
sir.
reaction? Right?
Yes, sir.
Now you can do these questions given the summary questions.
Yes, sir.
Right. Aditya, our next class will be on Thursday now. Will that be okay?
Okay, sir.
Coming Thursday? Is,
Yes, sir. Thursday is okay.
is it okay? And the time will be. Let me, just a minute. Thursday, 7 o'clock, 7 p.m.
Okay, sir.
Right?
Yeah, yeah.
Right. So I'm fixing a time on coming on Thursday, 7 p.m. Right. So
Yes,
by
sir.
that time, you go through all this and practice by writing, not just reading,
Okay, sir.
right? And whatever you practice, take a PDF and send it to me,
Okay, sir.
right? I'll be sending you some homework also,
Okay, sir.
right? On your email or on the WhatsApp, I'll be sending some homework. You do it that also, right?
Okay,
So
sir.
our next class will be on Thursday evening 7 p.m. I'll be covering the next topic after this, electroplating and purification proper and everything.
Yes, sir.
Okay, that's all for now. See you now on Thursday at 7 p.m.
Okay, sir. Bye,
Okay,
sir.
bye.